Alright, welcome to section 9.3, connecting graphs and rational equations. So our first example is going to be determining the roots of the equation 14 over x minus x plus 5 equals 0 algebraically. You've done very similar things before. Now, I don't like dealing with fractions, so the first thing I want to do is multiply everything by the smallest common denominator. So in this case, these are denominator 1, and so that means my smallest common denominator is x. So I'm going to multiply both sides of the equation by x here. So the opposite of dividing by x is multiplying by x. So I'm just left with 14 for that first term. And then x times x is x squared. And then 5 times x is 5x. And then equals 0. Next, I'm going to move everything I'm going to rearrange and then multiply by -1, just to make it so my x squared term is positive. So I'll end up with x squared minus 5x minus 14 equals 0. And now I need to factor this. So my factoring is going to be x minus 7 and x plus 2. So therefore, x is equal to -2 and 7. So now we found the roots. B, determine the x-intercepts of the graph of the corresponding function. So this is actually the same function. What this section is wanting to make sure you really know is that when we find the roots, it's the same as the x-intercepts. And again, you've done that before, but I graphed this in Desmos. So you can see that, yes, x is at -2 and 7. So perfect. Our question must be right. And then C just has explained the connection between the roots of the equation and the x-intercepts. Well, they're the same. Our roots are the x-intercepts of the graph. Let's take a look at another example. So this one's not as nice. It's not equal to 0 on one side. So we want to solve this equation graphically and express your answer to the nearest hundredth. So meaning we just have to type the left side of the equation as y1 and the right side as y2 into your calculator. Or if you're on a computer, you can use Desmos. So for Desmos, my left side is the red line and my right side are the blue lines here. And we're just looking for the intersection points. So x is equal to -3.34 to the hundredth. And then here 1.14. Okay, so let's write those down. So for A, we have x is equal to -3.34 and 1.34. So let me double check that second one. Yep, we're good. Okay, B, verify your solution algebraically. So just like in the last question, we want to get rid of these fractions. Now, some of these denominators can be simplified or at least factored so we can possibly have some more common factors between the denominators. That might save us a little bit of work. So I'll rewrite, this is 2 over 1. 3x, well, 2 you can't factor or do anything else, so we'll leave that. But on the right side, our denominator, we can factor 2 out. So it becomes 2 times 2x plus 5. Now from here, we're looking for different factors that are missing from each one. So like this one doesn't have our 2 or a 2x plus 5. This one does have a 2, but not the 2x plus 5. And then this one has both a 2 and a 2x plus 5, and it's not missing a 2 or a 1. So we're just kind of comparing from denominator to denominator. So the smallest common denominator is this 2 times 2x plus 5, because this one also has a 2. So I'm going to multiply everything by 2 times 2x plus 5. Now when I do that, this is going to cancel out with both of those. So my right side is just going to be my numerator. So that one's nice and easy. Now, in our first term here, there's nothing to cancel out with either of these. It doesn't have either of these factors. So it's just going to become 2 times 2 times 2x plus 5. And then in our second term, this minus 3x, well, there's a 2 to cancel out. So we just need this 3x times 2x plus 5. Now we can do the distributive property and start collecting like terms. So 2 times 2 is 4, and then I'll distribute that 4, so it'll become 8x plus 20. And then here we distribute the -3x, so it becomes -6x squared. minus 15x. And then on my right side, there's nothing I can simplify, so I'll leave that alone. And we'll collect some like terms. So I've got this negative 6x squared, and then I've got negative 7x. And then we just have that 20 is going to stay the same. Now we want to make one side equal to 0. I want my x squared to be positive, so I'm just going to add everything to the right side, or subtract this 20 as well. So that the left side is equal to 0. So adding 6x squared to both sides, I get 5x squared. And then if I add 7x, I get 11x. And then I'll subtract 20, and so I should get minus 19. Now from here, we need to either factor or use the quadratic formula. I know the answers come out to not very nice answers, so quadratic formula is going to probably be my friend here, so we'll use that. So it's x equals our negative b, so in this case 11 is b, plus or minus the square root of b squared, so 11 squared, and then minus 4 times a, so in this case a is 5, and times c, which is negative 19. And that's all going to be over 2 times a, which is 5. So you get two different answers here. You get our 1.34, and you get negative 3.34. So yes, it's been verified. So therefore, verified. Okay, let's look at one more example where we're going to solve a rational equation. This one looks a little bit tougher. We've got binomials in two of our denominators and a trinomial in the third denominator. My first step is going to be very similar. I'm going to make sure I can factor all the denominators as much as possible, or do any simplification. So there's nothing I can do in the first one or the second term. But in my third term, I do have a trinomial that can be factored, and it factors into x minus 2 and x plus 1. Now we're looking for, I'm going to put these little brackets here just to make it a bit more obvious that this is like a factor, this is a factor. So this first denominator, I'm just missing this x plus 1 compared to the other denominators. The second denominator, I'm just missing this x minus 2. So if I just multiply everything by x minus 2 times x plus 1, it should clear all the denominators out. So that's exactly what I'm going to do. X plus 1. So if I look at my first denominator, this x minus 2 is going to cancel with this x minus 2. So I'm just going to be left with x times x plus 1. And then in my second term, well, x plus 1 cancels out. So you're just left with the x minus 2. So we get 4 times x minus 2. And then here we have actually, in our right side, we get the x minus 2 and the x plus 1 that cancels out. So I'm just left with 6. Now I'm going to use the distributive property here. So x times x is x squared. And then x times 1 is x. So plus sign there. And then minus 4 times x is minus 4x. And then negative 4 times negative 2 is positive 8. We want this to equal 0. So we'll subtract 6 off both sides. And we'll combine like terms at the same time. So there's only one x squared. You get minus 3x, and then we'll minus 6. So you get plus 2 equals 6. And then we're going to factor this. So you get x minus 2 times x minus 1 equals 0. So therefore, x is equal to 1 and 2. Now we should verify this, and we should also check our NPVs here. I know we didn't do that on the last question, and luckily it didn't matter. For this one it will though. So because it's already factored here, our NPVs are x cannot equal 2 and x cannot be negative 1. So already we can actually get rid of one of these. It can't be this because of NPVs. So then we should do a left side, right side, and just check, is this 1 actually correct then? So our left side, and this is where x equals 1. And we'll just substitute 1 into all of this. So 1 minus 2 minus 4, 1 plus 1. And just start simplifying. So you get -1 minus 2 equal to -3. So then our right side is 6 over 1 squared minus 1 minus 2. So you get 6 over -2, which is equal to -3. So therefore, left side equals right side. And therefore, we know for sure that x is equal to 1.